Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 8 is on the screen. Let's get started, please. By now, it's Wednesday. You should be able to do all 3 of them by yourself. Okay. I'll give you guys some time. Copy and go. All right. Here we go. Being that it's Wednesday, I'm going to get some help from some of y'all. Let's go with number 1. Look at the green shaded region. Turn to your neighbor, let them know what inequality you wrote for the green portion only. Green portion only. What did you write? All right. Let's go with, how about Sarah? What did you write, Sarah? No. Just the inequality for the green part. Okay, so what is the dividing number? What number did it start with? Let's see. 1, 2, 3, 4, -4. All right, so far so good. And then the shaded region goes to the left, and all these are represented by which variable? It doesn't matter. I'm going to use x. So then all these numbers compared to -4 are what? Less than, and since it's a solid point, it's equal to. Okay. Hands if you got something like that. Okay. Let's go with the red part. Show your neighbor your inequality for the red part. Sarah's going to pass someone. Look at the red part. Pass someone, Sarah. Dayami. Okay, Dayami. Get us started. What is the dividing point? Okay, so this was -4. What is this one? -3. That is correct. 1, 2, 3. Yes. And then all this shaded region, I can't pinpoint a number, so I'm going to label those what? X. So what is -3 compared to all those numbers, Dayami? -3 is what compared to, let's say, 100 over here? It's what? Not right now. Yeah. Later. Yeah. Thank you. All right. Less than. Yeah. -3 is less than all those numbers, and since the point is solid, it's an equal sign. All right. Also, what did we say if there was a gap between the shades? We write what? Or. Oh, my bad. Sorry. Let it go. Let it go. Here you go. I'm going to talk about that. Some of you are just like, you don't want to let me know stuff. Let me know if I make a mistake or if I have something that's not working well. Let me know, please, because there is going to be a correction from something we did yesterday, a small correction that I missed. Some of you forgot to mention it, but I'll mention it today. Anyways, close it with a bracket, x such that, and close your bracket. There you go. All right. Inverse. Let's go with the inverse. Show your neighbor what you did for the inverse, and then Dayami's going to pass someone. What'd you do for the inverse? All right, Dayami, pass someone. Natalia Espino. Get us the first step. What is the first thing you do? Yeah, change f of x to y. That is correct. From there, we need to solve for x. Is that correct? So therefore, what do? Using inverse operations, we subtract 3. That leaves us with y minus 3 equals 6x. Am I done? Nope. Divide by 6. We end up with y minus 3 over 6 equals to x. Let me write that over here. Y minus 3 over 6 equals x. Is that the inverse? No, Mr. Q. Tell your neighbor what is going to make it the inverse. Tell your neighbor what to do to make it the inverse. Everyone, what makes it the inverse? Switch the what? The y and the x. You just switch them. So x minus 3 equals 6. I'm sorry, over 6 equal y. This is what we call the inverse. But we need to write it in function notation. So x minus 3 over 6 equals to f of x. However, to indicate that it's the inverse, you put a little negative 1 there. Once again, this is the third day doing these. Hopefully you're getting better at it. We're going to continue with these all the way till Friday. All right, go to number 3. Number 3. It says evaluate. So, all right. Check with the neighbor, see what they got for the first value, which is f of negative 2. F of negative 2. Tell them what you got for f of negative 2. And Natalia's going to pass it to someone. Natalia, pass someone. Hyman, what'd you get for f of negative 2? Negative 9. Hands if you got that. That is correct. So this one stays the same. And then we work on the right side. What is 6 times negative 2? Negative 12. Bring down the plus 3. What is negative 12 plus 3? That's negative 9. That is correct. Fine. Jaime from the corner. Let's go. All right. Next. F of. But now, I'm going to skip the 0 and go all the way straight to 1. Share with the neighbor what you got for f of 1. What you get for f of 1? Then Jaime's going to pass someone. F of 1. All right. Check with your neighbor, see what they got. F of 1, what'd you get? All right. Jaime, pass someone. Gio, what'd you get? F of 1 equals 9. Let's double check. We got a 1 here, 1 here. This is just a label, so it stays the same. What is 6 times 1? That's 6. Bring down the plus 3. What is 6 plus 3? 9. Gio from the corner. Let's go. All right. We good? All right. Check with the neighbor, see what they got for f of 0. F of 0. What they get for f of 0. It looks like Leo's got this. F of 0. Leo, what'd you get? 3. Hands if you got 3. That is correct. All right. Copy the agenda, please. Warm up number 8. Equations and inequalities. We're still in the middle of that. Today we're going to lean more towards inequalities because I want us to get more practice with that. Tonight's home plate, only 8 problems. Only. Copy that. Also in your notes, write this code down so we'll have access for the home play. Code JWM6U. 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 Now, if some of y'all, your Nearpod is not working at home for some reason and you're the only one, come see me afterwards, or right now when it comes up, take a screenshot from your Nearpod. Right now you'll see it when I send it to you, and like that at least you have it in front of you already. How about them apples? Ooh. No excuses, right? Let's go. So last night, there it is. Tonight. JWM6U. All right, and here goes another. Here, I put on your thinking cap. Focus, Carlos. Thinking cap, ready? Mr. Q, what else could I do if my Nearpod is totally not working? Where else can I go? Wait a minute. If I record the lesson on a daily basis and I show that on video, wait a minute. Where shall I go? To my YouTube channel. Bah. Go to the lesson and forward it to when I say home play. It should come up on the screen. Bah. Simple as that. Yes? All right. Anywho, look at your screen. That's tonight's home play. Yes? All right, get a Cornell note ready. I can solve one variable equations and inequalities. I can solve one variable equations and inequalities. I can solve one variable equations and inequalities. Tell your neighbor and remind them once again, what is the main concept we're still working on? What are we still working on? Yeah, one variable equations and inequalities. Yes. So, today we don't need a Ferrer model because we already know what one variable equations and inequalities are. And then I did a quick intro using the scale. You guys remember that? Yeah. I gave you guys a Ferrer model with all the definition, examples, non-examples. We created some hashtags. I told you we're going to follow a couple steps, simplify each side first, and then we need to isolate the variable or leave the variable by itself. We talked about one-step equations, yes? Baby equations, yeah? Aww. So simple. You just need one step to solve, yes? Then we went straight to two-step equations, yeah? Aw, snap. From there we went to multi-step equation using fractions, yes? Then we did more multi-step equations like so, like so. Then we got to this inequality. However, I want to talk about this one because some of you didn't catch it. I didn't catch it because it went pretty fast yesterday, but I caught it once everybody left. I'm like, I forgot to tell them. Anyways, copy that one. Let's do this one more time on your notes, please. Copy that one. We're going to label this one example Q. Example Q. Copy this, please, in your notes. Example Q. All right. Yes? Yeah, today, since it's a continuation from yesterday, we're not doing the box. I asked you guys not to do the box, right? All right, good. All right, here we go. Y'all ready? Negative 8x minus 21 plus 5x less than or equal to negative 15. Draw your line down the inequality symbol. All right, let's focus on the left side. Can we simplify the left side? Yes, Mr. Q. This one is like that one. Okay, let's combine them. If you owe me, because that's a negative, if you owe me $8 and you only have $5, that leaves you with owing me what? $3, so negative 3x. Bring down the negative 21, bring down the inequality symbol, and negative 15. Since I cannot simplify both sides anymore, I need to leave x by itself. So, using inverse operations, what is the opposite of negative 21? Plus 21, plus 21. Bring down the negative 3x. Less than or equal to 21 minus 15 is 6. Next, we still need to leave the x by itself. Negative 3 is multiplying, so what is the inverse? We divide by negative 3, divide by negative 3. X less than or equal to negative 2. Now, here yesterday, I've seen some of y'all and your family is driving, some of you just roll through those stops. You get to the stop and all of a sudden you don't even stop and you just roll through it. I rolled through this stop. Remind your neighbor, what happens to this inequality symbol when we multiply or divide by a negative? See if they remember. What happens to that inequality symbol? It flips. It goes the opposite direction, yes? So watch. Let's go. I love technology. So now instead of less than, it's what? Greater than. Yeah, so make a little note for yourself on the side so that you remember to do that. Put a little asterisk, put a heart, aww, and then make a little note whenever you multiply or divide by a negative, you flip and then point to that. You flip it. Okay. All right. Next, let's graph this. Again, yes, again. So make a number line. And here's 0, 1, 2, 3, -1, -2, -3. All right. First, here goes the process. Today we're going to hammer this to make sure we got it. Okay, here goes. We start off with a number that is part of our solution. What is that number? -2. So go to -2. You're going to do an open point first. So there's my open point. You guys see it? Yes. Then you're going to come back over here and check, does this inequality have an equal sign? Yes. If it does, fill in the point. Next, this is called, and I'm going to be very clear on this, this is called a dividing point. Why is that called a dividing point, Mr. Q? Because it divides the number line into solutions and no solutions. Let me repeat that again. It divides the number line into what? Solutions and no solutions. So now the trick is to find out which way am I going to shade it. Do I go to the right or do I go to the left? So here's the way of doing this. Pick a number, any number that you see on the screen. I'm going to pick this one, -3. Okay? So I want to pick that one, and I'm going to check by substituting in here, and if it is true, I'm going to shade everything to the left. However, if it's not true, I'm going to shade where? The opposite direction. So let me substitute that in here. Instead of x, I'm going to write what? -3. All right? Bring down the inequality symbol and the -2. Let's read that. It reads, is -3 greater than -2? So let's look at the number line. We know that all the numbers to the left are smaller. Is that correct? So is -3 greater than -2? No. So I'm not going to shade that way. Which way am I going to shade? In that direction. Yes. Right. So this is where I'm going. You guys have survived on shortcuts. I want you to understand what it means. You see what I'm saying? I want you to understand why do we shade in one direction, not because it's the arrow's pointing that way. No, I want you to think about it because these numbers do not work. That means all the other numbers should be what? The solution. That's why this is now solutions. Solutions. And what would be to the left, everyone? No solutions. That is correct. That's why this is called the dividing point. Are we there? All right. So, since this is our solution, look up. Let's write our solution set. Here it goes. Solution set, x, such that, leave an empty space, and close the bracket. That is going to be automatic from now on. Bread and butter. Now let's read first. What this is actually a statement. It reads, the set of that and that mean that. The set of what? Let me circle the x. All x's. All x's. And last but not least, this bar means such that. Such that. Okay. So let's read this completely. The set of all x's such that what? What was our solution? x is greater than or equal to negative 2, and then you close the bracket. Are we doing? Yes? All right. Send me your notes, please. I want to see what you did. It took a little bit longer, but I just wanted to cover the flipping of the symbol and then how to write your solution set and the graphing, how to test the graph. All right. So even though we've only done one so far, how comfortable are you with inequalities from 1 to 5? 1 being the lowest, 1 being the highest. We got 3s, 4s, 4s, 5s. Okay, we're getting there. Let's do another one. Copy this one, please. Example, this is going to be example 2Q. Example 2Q. And it says 5 parentheses or times p minus 2 close parentheses greater than or equal to negative 15. All right, let's do this one together. Here we go. Line down the inequality symbol. So look at the left side. Can we simplify this? Tell your neighbor what to do, please. What do we do here? Yeah, when you see a parentheses, distribute. So multiply that times that, that times that. So this is 5p minus 5 times 2 is 10, greater than or equal to negative 15. Now this looks familiar, yes? So let's leave p by itself. So what is the inverse of a negative 10? We add 10, add 10. Bring down the 5p, greater than or equal to, this is negative 5, or negative 15 plus 10 is negative 5. Last but not least, we still need to leave the p by itself. 5 is multiplying. What is the opposite? We divide by 5, both sides. P is greater than or equal to negative 1. Notice we divided by a positive 5. Is that correct? That's why we didn't flip the symbol. Even though this number over here already had a negative, that's why we didn't flip it. All right, let's graph that. Zero, 1, 2, 3, negative 1, negative 2, negative 3. All right, let's see if we got the process. What is that number? Negative 1. What did I ask you to do? Start with an open point. There it is. Next, you check over here on the inequality. Does it have an equal sign? Yes, so we make it a solid point. Next, I want to shade in which direction. I don't know. So that means I need to check a value. Which number would you like to check? Give me a number, people. 1. Okay, I'm going to use 1. All right, so we substitute 1 there. Is 1 greater than negative 1? Is it equal to negative 1? No, but at least it's what? It's greater. So this is true. So if this is true, that means you're going to shade in that direction. All right? Let's write our solution set of x such that, and what goes in there? P is greater than or equal to negative 1. How are we doing? Good? All right, send me your notes, please. All right, copy this one, example 3. Example 3. Example 3. Yes. We got 2x plus 1 over 3 less than 7. 2x plus 1 over 3 less than 7. Two x plus 1 over 3 less than 7. All right, do this one together. Line down the inequality symbol. Can we simplify this side anymore? No. How about this side? No. Okay, so let's start by leaving the variable by itself. What's going on? There's addition and there's division. So, for those of you that forget where to start, remember when we, let me take you back in time. The order of operations is as follows. Please excuse my dear Aunt Susan. Yeah, I don't have a salad. All right. So, that's the order of operations when you take a number and all of a sudden you do stuff to it and then you end up with an equation. How about when we want to get the number by itself? We go backwards. Is that correct? So where do we start? Addition and subtraction, but in this case, we have this in there that we can't really get to the x. So that means the second thing we get to is what? Multiplication and division. So let's start there. So if the 3 is dividing, what is the opposite of division? Multiplication. So we multiply times 3, multiply times 3. So we're left with 2x plus 1 less than 21. From there, you should be able to finish it off, graph it, and write your solution set. I'll give you guys some time. Go. All right, help me finish this up. Show your neighbor what you did. You should be already done solving it. You're probably writing and graphing at this time. Check with the neighbor, see what they did. All right. All right, good. So what should I do from there? Help me out. Let's go with Alexa. Alexa, what do I do next to leave x by itself? Subtract 1 from each side. That is correct. We're left with 2x less than 20. And everyone, what is our last step? Divide by 2. Divide by 2. X is less than 10. Hands if you got that. All right. Let's go with the graph. The graph. Here it goes. We got this one. We have to go all the way to positive 10. Look what I'm going to do with a 0. Instead of placing it in the center, I'm going to place it somewhere over here. Okay? All right. Guide me through this, Julian. What do I do? Open circle on the 10. Does it stay open or do we close it? Stays open. Everybody, hands if you got open point. Yeah, why? Because there's no equal sign. Okay. What number would you like to check, Julian? 5. Okay, so we substitute 5 in here. Is 5 less than 10, everyone? Yes, so that means we're in a shade towards 5. And last but not least, solution set of x such that x is less than 10. All right, send me your notes, please. From 1 to 5, how comfortable are you with these so far? Where are we at? 5, 5, 4, okay. Example 3Q. Example 3q. Very similar to the one we just did. It says 8 is less than or equal to 3x minus 4 over 2. See how you do with that one. And go. All right. All right, let's do this, Eileen. I'm going to help you out. Ready? There you go. That's good, right? All right, what do I do first, Eileen? What's the 2 doing? Therefore, what is the inverse? What is the opposite of? Yeah, you multiply times 2, both sides. So we end up with 16 less than or equal to 3x minus 4. Continue, Scarlett. Add 4 to each side. That's 20 less than or equal to 3x. Continue, Michelle. What do I do next? Divide by 3, divide by 3. 20 divided by 3 is 6.6 bar. Is that correct? Yes? Less than or equal to x, or 6 2/3. I'm going to leave it at 6.6 bar. Bar meaning that it continues. All right. Hands if you got something like that. All right. Graph. Go. One, two, three, four, five, 6, 7, 8. -1, -2. All right. Guide me through this one. Let's go with Miguel. Tell me what to do. A closed circle between 6 and what? A closed circle between 6 and 7. All right. Then what number would you like to test? Let's test 8. All right. So we got 6.6 repeating less than 8. Is 6.6 less than 8, everyone? Yes, that is correct. It is true. That means I'm going to shade towards that. There it is. Ooh-wee. And then our bracket, solution set of x, such that, and what was our solution? 6.6 repeating is less than or equal to x. From 1 to 5, I'll come to you with all of that. Where are we at? 4 5s, 4 5s. Okay. Send that in, please. All right. Then that one, we did an equation that looked like this. We're not going to do that one. We did one like this, like this. Well, let's do this one. Copy this one, please. Example. I'm going to call this one Michael Jordan Q. How about them apples? MJQ. So we got 2 parentheses, 3a minus 1, close parentheses, greater than 3a plus 7. All right, here goes the line down the equal sign. Turn to your neighbor, let them know the first thing you're going to do on the left side. And then I'm going to have Diana get us started. Check with your neighbor, tell them what to do really quick. All right, Diana Gomez, what do I do? Distribute, so what do you write? minus 2 greater than 3a plus 7. Question, guys, can I simplify the left side anymore? No. How about the right side? No. Tell your neighbor what to do next. What do we do next? Now that we have variables on both sides, what do we do next? Oscar, what do we do next? Yeah, he said start with the smallest variable. What is the smallest variable? 3a. So what is the opposite of 3a? Negative 3a to each side. That leaves us with 3a minus 2 greater than 7. All right, continue from there. What do I do next? Martin. To leave 3a by itself, what do? Add 2 to both sides. We have 3a greater than 9. Okay, let's see. Last step. Divide by 3 both sides, so a is greater than 3. Say that again. So good question, Julian's all, Mr. Q. We always start with the smallest variable. Let me tell you why I start with the smallest variable. Because if I was to start with a large variable, look, I would subtract 6 from each side, and then I'm going to end up working with negatives, which at the end we would have to do what? Flip the symbol, which some of you might forget, like I did yesterday. So if we start with the smallest one, we're going to end up with positives all the way through to the end. Yep. But you could have started with either one. All right, let's graph that, please. And write your solution set. Let me send you the screen so you can send me that. Give me a second. There it is. No, because the variable is going to be on the right side instead of the left side. Yeah, even if it flips. Yeah, at the end, even though you were going to work with negatives, you're going to compensate the arrow with the negative when you do the last division. Yeah. All right. All right, for the sake of time, I start with my point, which is at 3, and it's an open point. It doesn't have an equal sign. I'm going to test a number. What number shall I test, everyone? All right, I'm going to test 0. So 0 greater than 3. No. So I'm going to go to the opposite direction, and that's my solution. So solution set of x such that, oh, my bad, instead of x, it's a. My bad. Solution set of a such that 8 greater than 3, close bracket. All right, we'll stop right there. Log out, please. Once again, put in some work for your home play. Those of you that are following on YouTube, see you guys next time.